Good morning. Today let us study about high spin, low spin equilibrium and what is spin crossover phenomenon. What is spin crossover phenomenon in metal complexes? Let us see in metal complexes there are two types of complexes formed. In transition metal complexes there are two types of complexes formed: high spin complex and low spin complex. You have already studied. Okay, you know that. Depending upon the two factors, there are two factors affecting the nature of the complex formed. Remember, there are two factors: crystal field stabilization energy and pairing energy affect the nature of the complexes formed. For example, there are three cases depending upon the two factors: crystal field stabilization energy and pairing energy. Case 1, when delta is greater than pairing energy, when crystal field stabilization energy and crystal field splitting is greater than the pairing energy, and also in the that means in the strong ligand field, when 6 ligands approach, for example, when 6 ligands approach, in the absence of ligand field, they are degenerate. The d orbitals are degenerate in the absence of ligand field in the gaseous state. For example, Fe2 plus in the gaseous state, it is degenerate. When 6 ligands approach, the d orbitals split because of crystal field splitting, because of ligand field splitting. Okay. Therefore, when delta is greater than the pairing energy in the strong ligand field, then it forms low spin complex. It forms, for example, here I have shown here in the case of ferrocyanide hexacyanoferrite 2 complex, it forms low spin complex, as you see here. And as we go down in transition metal series, as we go down, this is 3D series, this is 4D series, this is 5D series. In the case of 3D series, only in the presence of strong ligand it is low spin, whereas low spin complex is formed. Whereas in the case of ruthenium 4D, 5D series, the crystal field splitting is large. For example, iron this much and ruthenium this much and osmium this much. So the crystal field splitting is very much greater. It increases down the group. The crystal field splitting increases. Therefore, even in the weak ligand field, it forms low spin complexes. Okay, low spin complexes. I have shown here in the case of crystal field stabilization energy is greater than pairing energy. There are 6 electrons, D6. So I have put 6 electrons here. The d orbital splits into 2 levels, T2G and EG. The d orbitals split into 2 levels, T2G level and EG level. They are separated by crystal field stabilization energy. We have already studied in crystal field stabilization energy. Case 2, now we will see. In the case of high spin complex, the pairing energy is greater than crystal field stabilization energy. It is opposite. In the case of high spin complex, high spin transition metal coordination complexes, the pairing energy is greater than the crystal field stabilization energy. For example, iron in the weak field ligand, it splits into 2 levels, T2G and EG, and crystal field splitting is very, very small. The same pairing energy is greater. In this case, the pairing energy is greater than crystal field splitting. Therefore, there are 6 electrons similarly, +2 state, it is in the +2 state. Therefore, there are, you add 1, 2, 3, 4, 5 first according to Coulom's rule of maximum multiplicity, and then you add one more electron here. Therefore, there are 4 unpaired electrons. Here there are no unpaired electrons. Here there are 4 unpaired electrons because of pairing energy is greater than crystal field stabilization energy, and also in the weak ligand field, the crystal field splitting is very, very small. Okay, so the pairing energy is greater than Cfse. Okay, in the case of third case, when delta is equal to pairing energy, when delta is approximately equal to pairing energy. Okay, then there exists high spin, low spin equilibrium. Remember, then delta is approximately equal to P. There exists high spin, low spin equilibrium. That is, this phenomenon is called spin crossover phenomenon. That is, high spin is converted into low spin, and at the same time low spin is converted into high spin. For example, Fe, Pn twice, NCS twice, where Phen equal to 1,10 phenanthroline. Okay. Now let us see a problem asked in CSIR NEET 2015. The complex, especially this complex, shows spin crossover behavior. Calculate the crystal field stabilization energy and the spin only magnetic moment. Mu effective is spin only magnetic moment at 250 Kelvin and 150 Kelvin. What are that? You are asked to calculate the crystal field stabilization energy, spin only magnetic moment. Okay, as I said earlier, at high temperature, for example, at high temperature, high spin exists. The complex exists, the coordination complex exists in high spin state. At low temperature, it exists in low spin state. Okay, so let us see first at high temperature. At high temperature, 250 Kelvin, it exists in high spin state. Therefore, the crystal field stabilization energy, high spin state. So this is the high spin state. This is low spin state. Okay, this is low spin state. Therefore, 4 into 4. There are 4 electrons. 1, 2, 3, 4. Therefore, 4 into minus 0.4. Then plus 2 electrons are there into plus 0.6 delta. Therefore, equal to minus 0.4 crystal field stabilization energy. Okay, now the spin only magnetic moment is calculated by using the formula square root of n into n plus 2 equal to, for example, in this case there are 4 unpaired electrons, n equal to 4, 1, 2, 3, 4. Therefore, 4 plus 2, 6 into 4, 24. Therefore, square root if you take 4.9, 4 magneton at 150 Kelvin. Then you calculate crystal field stabilization energy, mu effective at 150 Kelvin. At 150 Kelvin, at low temperature, this is high temperature, this is low temperature, it exists in low spin state. It exists in low spin state. Therefore, delta equal to, this is low spin state. Therefore, delta equal to 6 electrons. There are 6 electrons into minus 0.4 equal, and this is 0. Therefore, equal to minus 2.4. The mu effective, the spin only magnetic moment is calculated. Here there are 0 unpaired electron. Therefore, n equal to 0. I am substituting in this formula 0, 0 plus 2, 0 into 0. Therefore, 0 growth magneton. Okay. So this is the spin crossover phenomenon occurs especially when the delta value is approximately equal to the Planck energy. This may be asked in even NEET, JEE also. Please understand. Then you can solve any type of problems. Thank you for watching.